Number 9. 71 first graders run in a gymnasium class. Two high school students, Nick and Serg, received a list of names of these first graders and got a task to put the names in an ascending order of height of the first grade students. What is important is that it is known that all of them have different height. Nick and Serg decided to do the following. Nick reads names of some 3 students from the list, and Serg catches them and tells to Nick who of the 3 has the intermediate height. Nick cannot see that by himself, he just heard Serg's words. This last statement, it means that Nick doesn't know the tallest and the lowest students from the pair of students left. The question is, what maximum number of the first grade students can Nick put correctly according to height to a reordered list after 1225 answers of Serg? To begin with, let's show that regardless of the number of questions, it is possible to reliably identify the position of no more than one student. Imagine that we have 2 groups. Group number 1 and group number 2, which are absolutely the same in terms of height of students. The students here are arranged in decreasing order of their height, and the only difference between these 2 groups is the names of the students. For example, in the first group, the tallest student's name is S1, and in the second group, the name of the tallest student is S71. So, the order of the name is just reversed. Obviously, Serg will give absolutely the same answers to all questions in these 2 groups. For example, let's take 3 students, S2, S6, and S70. In the first group, S2 is taller than S6 and S6 is taller than S70. So H2 is greater than H6, which is greater than H70, where H stands for height. In the second group, the situation is the opposite. So H70 is greater than H6, which is greater than H2. But we can see that the student with intermediate height is the same. So here and here, H6 stands in the middle, which means that the answer for both groups will be the same, and it will be H6 or student with name S6. Now I think that you feel better the statement that Serg will give the same answers to all questions in the group. Okay, now let's assume that using the method described in the tasks, in this task, boys can correctly identify the position of some student from the first group. Then their method should be able to demonstrate the equivalent result in the second group, since in the task we are talking about some universal method of identifying students' positions in the arbitrary group of 71 students. Notice that our Serg will give the same answers on questions about students with names SI and S72 minus I. From the first, so this is from the first, and from the second group correspondingly. due to the fact that these two students will be absolutely the same in terms of height. Let's see an example. If I is equal to 1, then here we have S1 and here S71. And we can see that the student S1 from the first group and the student S71 from the second group they have the same height. Okay, so since both groups are equivalent for us and we even don't know the group from which we're choosing, since the names are the same, the heights are the same. The difference is in the corresponding between the names and the height of the student. So boys can uniquely identify the student if and only if the names are the same. So the subindex I here equals to subindex 72 minus I. So the name is the same. I equals to 72 minus I, which gives us I that is equal to 36, which stands for an intermediate student. Now we know that boys can determine the position of only one middle by height student in case of unlimited number of questions. Now we have to check whether it is possible to do within the number of questions that is given in the task. And in the task we have this 1225 questions. Okay, now let's show how to determine the central, or as we named him, intermediate student using given number of questions. We will achieve this goal by repeating the procedure of finding extreme students in terms of height. So assume that we are given K students. Then, by using K minus 2 questions, it is possible to determine a pair. It is possible to determine a pair of the lowest and the highest student in this group. And the highest students in this group. In this group of K students given for us. And now that we'll do it without specifying which of them is actually the lowest and the highest. So we are interested in this pair, not in particular lowest and highest student. Okay, so how it can be done? Well, the first question we'll ask in arbitrary way. For example, we had S2, S6, and S70 in our example. Then we receive an answer. We know that S6 has intermediate height, and now we mentally cross the student out from the group. So we have a group with 71 students, S1, S2, and so on, S6, and so on, S71. This is our first question. We know that S6 has intermediate height, and we cross it out. Then we ask another question about students from our new group, S1, S2, and so on, S5, S7, so without S6 here, and so on, S71. We, for example, ask another question like S1, S2, S71. We know that this student is an intermediate student, and we'll cross it out and move to the next step. Obviously, our lowest and highest students cannot be crossed out in this way, so we'll never cross out this S1 and S71. These two students are extreme in terms of height in these two groups given in the example. Okay, and notice that if there are more than two students who are not crossed out, then we should continue to ask our questions. So here we have on the first half we have 71 students, here we have 70 students, and at some particular moment after several steps we'll have only two students, S1 and S71, and this will be our last step. So here we understand that we can stop the procedure. So the process will stop if and only if our boys will be left with exactly two students. And since we cross out one student at each step, then we need to ask k minus 2 questions, this k minus 2 questions, to have this particular two students remaining. Okay, using this procedure, we'll find the lowest and highest student at each stage of the process. At the first stage, we'll find some extreme students from the students of our group. For example, so now we move to another process of finding extreme students from our particular group. We have a group once again. Where is it? Yeah, so this one. This is our group of all students with this S6. We use the procedure above to find these two students, so S1 and S72 minus 1. Now we cross them out as two extreme students. And this is our first step. On the next step, we'll have our new group without these two students. And we will find extreme students from this new subgroup. So we'll find this S2 and S70 and we'll cross them out. So on the next step we'll have S3 and so on, S69. So at the first stage, once again, we'll find extreme students from all the students in the group. Then we will remove these two students, S1 and S71. We'll remove these two students, and at the next stage, we'll find a new pair of the lowest and the highest students from the subgroup, from the group without these two students were removed at the first stage, and so on. So obviously, after several steps, we will have one student left. So after several steps, we'll have one student left, and this will be our S36 in our examples. So this is the middle one we wanted to find. So how many questions do we need to ask to find this particular student? And according to the question, according to the description of our process, to find the central student, we need k minus 2 questions at each stage. So here k is 71, here k is equal to 71 minus 2, so it's 69, and so on. And at each stage we'll need this k minus 2 questions to find this pair of the lowest and the highest student. So once again, at the first stage, we'll need 71 minus 2 questions to find S1 and S71. Then we'll need 69 minus 2 questions at the second step to find S2 and S70. At the next stage, we'll need 67 minus 2 steps, and so on. And at our last stage, we'll have S35, S36, and S37. So we'll have 3 students, so we'll need 3 minus 2 questions here to move to our answer S36. Okay, so we need 69 plus 67 plus 65 plus and so on plus 1 questions. And that is an arithmetic progression. So the initial term here, A1, is equal to 1. We have n terms, where n is equal to 69 plus 1. So the first term plus the last term divided by 2. And our nth term, an, is equal to 69. And the common difference here, d, is equal to 2. And the sum of n terms of the arithmetic progression, Sn, is equal to a1 plus an divided by 2 and multiplied by n. This is equal to 69 plus 1 divided by 2 multiplied by 69 plus 1 divided by 2. So it's 70 divided by 2 squared, which gives us 35 squared, and this is equal to our given number of questions, so 1225. Yeah, and once again, this is the number of questions we are given in the task. You can see it right here. So this is how many questions we need to identify the intermediate questions. And this is equal to the number of the given questions. So therefore, boys have enough questions to determine the central student in terms of height. So once again, we know that using unlimited number of questions, we can determine only one central, or let's name it intermediate, student. And now we know that we have enough questions to determine this one intermediate student. So the answer on this problem is just one. We can determine only one student having unlimited number of questions, and we have enough questions to determine this one particular student. So our answer is 1, and this student is also an intermediate, essential one.